This tutorial, I'm going to show you how to use the DFRobot URM09 ultrasonic distance sensor. I've got a box that's kind of moving closer to the sensor, and I'm just kind of moving it away. And you can see that it's pinging itself and getting a distance measurement the further away that I move the box. So I'm going to show you how to set this up. It uses i2c, and it also uses very few connections. To get connected, you're going to use a program called Terraterm, and it's free. So what you're going to do is going to come up to File, New Connection, and you're going to select Serial. In this case, I'm going to use COM8. It should come up with something like COM6 or COM5, but you can just kind of select one and just hit OK. And if you hit the enter key on your keyboard, you should see something like this show up. So if it doesn't show up, just try another COM port until you see something like this. So the next part, you're going to come up to Setup and Serial Port. And next, you're going to make sure that this is set to 38400. And you might want to copy these settings, but these are good to go. So I'm just going to hit the X over here. And next, what we're going to do is I've got two programs already written. I've got a Hello World written to Flash and a distance program. But before we get to this program, I'm going to show you how to do this line by line so you know how this works. And this is a link to the page of the sensor that I'm using. It's an ultrasonic distance sensor, and I'm using version 3. But you should be able to use it on 1, 2, and 3. I've written code, and these are pretty similar. So it accepts a voltage from 3 to 5, and the measurement range is going to be 2 centimeter to 500 centimeter. So it's good for close to medium range with the resolution of 1 centimeter. Here's your connections: power, ground, clock, data. So here's your pin and the description. So it's simple to connect it up to the Pi Pico, and you want to pay attention to the slave address, which is going to be hex 11. So we'll be using this number a lot. I've got a pinout of the device, and I'm going to be using VBus for power, and I'm just going to use this ground that's close by. And if you want to follow along, I'm going to be using GP0 for the SDA line. And next, I'll be using the GP1 for the clock. So you want to keep track of the GP1 value and the GP0 value. So we'll be writing this into our piece of code. So to configure the pins for i2c, they have a command called SetPin. And we're going to set GP0, GP1 for i2c. So once you do that, they should be set. Next, we're going to open those pins for i2c. So just type in i2c open, and we'll assign it a bus number. In this case, we'll just assign it 100, but you can pick any number that you want. And the next, we'll be assigning it a standard rate of 100 kilohertz. So we're just telling the i2c device to run at that speed. And this is kind of standard across a lot of i2c devices. So just hit enter. And next we're going to create a buffer. So we'll just type in this and we'll create a buffer. So we got our buffer set up, and this is going to accept our number of bytes that we receive from the device. And the 2 bytes that we'll be receiving is the least significant byte and the most significant byte. So we'll store it in the buffer. We'll combine it, and we'll get our measurement. So to start writing to these registers, you're going to pull up the datasheet. In this case, I'm using version 3 of the device. And the important thing you always want to search for is the slave address, which in this case is hex 11. So we're going to be using this number quite a lot. And it says that if you write into this register, so if you write into the 11th, if you write into hex 11, and you write into the 0 register of this device, you can actually change the slave address. So if you have a conflict with another device, you can always change this slave address. Also, when you're testing things out, you want to be super careful of writing into this 0 register. When you go to unplug the device and replug it back in, it may not work because you've changed the address. So be super careful of this. And in the future, I'll teach you how to write your own i2c scanner in MMBASIC. This is kind of a standard thing in FlashForth. All it does is just list your device out. And you can see the screenshot. It just shows that my device is actually on 11 or hex 11. So if you're interested in that, subscribe and I'll do another video on this. So moving along, we're going to write a 1 into the 8th register of this device. So this is going to be a passive measurement. We're just going to take a single measurement, and this is going to, we can put this in a loop. So I think that's the easiest to set up. We're also going to write a 0 into the 7th register. So this is just going to set it as a passive measurement, but we can set it as automatic measurement. And I think in this case, this one is the easiest one to set. So after that, once we take a measurement, it's going to dump the values into these 2 registers, which is going to be 3 and 4. So we do a bit of math on these 2 things and we get our measurement. So let's set it up for passive measurement. Just type in i2c and we're going to write into, or the slave address of 11. We're going to type in 0. We're going to send it 2 bytes. And we're going to write into that 7th register. So 07. And we're just going to write a 0 into the 7th register to set this for passive measurement. So we got that. On your keyboard, just hit the up arrow. And we can change this to an 8. And we can change this to a 1 because we're going to take a single measurement. And I think that's all we need to do for that. So just like that, we took a single measurement. Next, we're going to pull out the value that we put into the least significant byte. So that's going to be in register 3. So we're just going to write into our address and we're going to just send it the hex address of 3. And that's all we need to do. So hit enter and we'll perform a read. So read, and we're going to read from that. So all we need to do is type in 0. We're going to get 2 bytes, put it into our buffer. And we've got it. So all we need to do is just type or print it out. And we got 0. Just type in 1. And we got a number right there. So that's kind of our distance, which was 53 centimeters. So we're going to come up here, type in flash list. We're going to enter into that distance, which is in slot 2. So we'll just type in flash load 2. So that should be loaded. Just type in edit. And this is the program that we're going to run. So you can see we're going to set up our device in passive measurement. So we're going to write to the 7th register, put in a 0. And down here, you can have optional to just pause it for 10 milliseconds. And we're just basically kind of putting this all in a loop. Next, we want to flash our program and run it. So just type in flash list. We want to load slot 2, which is our distance program. So flash load 2, type in edit, and this is our program. So at the top, you can see the name of our program. Anytime you want to name it, just type in a single quote followed by the name, and it will show up in slot 2 or wherever you save it. So here we're setting our pins up as I2c. we're opening the I2c for I2c communication. We got a buffer that can accept 2 bytes. We're writing to the 7th register a 0 to set it as passive measurements. So we're only going to take 1 measurement. And this is kind of our main loop. So from here, we have the option to set a pause of 10 milliseconds if we want. So I could uncomment that and have 10 millisecond pause. Here we're taking a measurement. So writing to the 8th register a 1 takes a single measurement. After that, we're writing to the 3rd register to read it. So after we write to this register, it should output some information for us. And down here is where we're able to read it. So we're sending it into that buffer and we can accept 2 bytes into this buffer. So all we're going to do is print it out. So this is kind of a simple example. I'm just going to hit escape and we can just run it. So you can see it's running. Put something kind of close to it. You can kind of see the values change. So that's how you can put this in a loop. So I just wanted to show this as a simple I2c example. You can extend this sensor range by writing into the 4th register, but as it is, you can only take a value or a reading from 0 to 255 centimeters, which is about 8 feet. So you can still extend this code and extend the range of the sensor. I just didn't write this because I wanted to show how you actually, work with a datasheet, MMBASIC, and put it all into code. So you can take this knowledge and apply it to other I2c devices. So if you like this video, like, subscribe, and let me know what you think.